So today we are going to learn about Newton-Cotes quadrature and also Rombergs integration method. Now Newton-Cotes quadrature, let I be an integral a to b y dx where y equal to f of x takes the values y0, y1, y2, etc. yn for a equal to x0, x1, x2, etc. xn equal to b. Let us divide the interval a and b into n equal segments of width h such that a equal to x0 less than x1 less than x2 etc. xn minus 1 less than xn equal to b. So this is y equal to f of x. They are divided into equal number of segments. Now for each segments there is different formula. So this is segment 1, segment 2, segment 3 etc. and go on. Okay. So for each segments there are different formulas. So in case of segments, if there are two segments, then formula is b minus a into f of x1, and segment 3 it is b minus a into f of x1 plus f of x2 by 2, and if segments is equal to 4, then it is b minus a into 2f of x1 minus f of x2 plus 2f of x3 by 3. And for 5 segments, b minus a into 11f of x1 plus f of x2 plus f of x3 plus 11f of x4 divided by 24. Then in case where there are 6 segments, then equation is b minus a into 11f of x1 minus 14f of x2 plus 26f of x3 minus 14f of x4 plus 11f of x5 divided by 20. Okay, so these are the different formulas for each segments. So we have to keep in mind all this. So in case of 6 segments, in the formula we have to make a small change, that is 11f of x1 minus 14f of x2 plus 26f of x3 minus 14f of x4 plus 11f of x5. Okay, so I forgot to put x5 there, so you have to correct it. 11f of x5 divided by 20. Now let us solve a problem. You have to compute integral 1 to 2 1 by x dx using midpoint formula or Newton-Cotes quadrature formula. So take h is equal to 0.5. H is nothing but the step size. Okay. So here we are dividing it into 4 segments. So dividing it into 4 segments. So 1 is taking step size as 0.25. Segments will be 1, 1.25, 1.5, 1.75 and 2. Sorry, the points will be 1, 1.25, 1, 1.5, 1.75 and 2. And these are the segments: 1, segment 1, segment 2, segment 3, segment 4. So in case of 4 segments, equation will be b minus a into 2f of x1 minus f of x2 plus 2f of x3 divided by 3. So f of x1 will be what? F of x1 equal to 1 by x. So that x value is nothing but the point between the segment, that is, this is f of x1. and this is f of x2 and this is f of x3. 1 and 2 are the end nodes. Okay, so while finding f of x1 you have to replace x by value 1.25, and finding f of x2 you have to replace the value of x by using 1.5, and for finding f of x3 replace x value with 1.75. Thus you will obtain values for f of x1, x2 and f of x3. Now substitute these values in this equation. Here B and A are the end nodes, so B is 2 and A is 1. Substitute the values and find the value of the integral, that is equal to 0.6909. So this is the value of integral 1 to 1 by x dx. So this is how to calculate the integral formula, value of the integral using Newton-Cotes quadrature. Next we have to study about Romberg integration. So first we can go through the derivations, and this derivation is not important. So it's just to make you show how you are arriving to that equations. Okay. So no need to study this derivation. You have to finally study only this table. So here, let I be an integral a to b f of x dx. Let's improve the value of the integral by trapezoidal rule. So if I1, I2 are the values of I with intervals of width h1, h2 and e1, e2 be their corresponding errors, then I equal to I of h plus e of h. So taking I1 and I2, I of h1 plus e of h1 will be equal to I of h2 plus e of h2, is it? Now taking the ratio e of h1 by e of h2, value will be h1 square by h2 square. So here e of h equal to minus b by a by 12 h square f double dash of x. This is an error formula. Okay, this is an error formula. So by taking the ratio, you will get it as like this. Now e of h1 equal to e of h2 into h1 square by h2 square. So you know I of h1 plus e of h1 is equal to I of h2 plus e of h2. Now you are substituting the value of e of h1 in this equation. So on substituting, equation turns out to be like this. So on rearranging, you will get e of h2 is equal to I of h2 minus I of h1 by h2 whole square minus 1. So you have I is approximately equal to I of h2 plus e of h2. Now substitute the value of e of h2 in this equation. Now when h1 is equal to h by 2, substitute h1 equal to h by 2 in this equation, then you will get value of integral I as 4 by 3 I of h2 minus 1 by 3 I of h1. And when h2 is equal to h2 by 4, equation turns out to be I equal to 16 by 15 I of h2 minus 1 by 15 I of h1. So finally, you have to remember only this table. Okay. So while using Romberg integration, value of I2 double dash will give you the value of the integral. So finding this I2 double dash, you have to know the value of I2 dash, I1 dash. And to get the value of I2 dash and I1 dash, you should know the value of I0, I1, I2. So here h raised to 2, h raised to 4, h raised to 6 are nothing but the orders. So while solving a problem, you will be more familiar. So I1 double dash, the value of I1 double dash is equal to 4 by 3 I1 minus 1 by 3 I0. Value of I2 double dash is equal to 4 by 3 I2 minus 1 by 3 I1. And for value of I2, so I2 double dash will be equal to 16 by 15 I2 dash minus 1 by 15 I1 dash. So you have to remember this table. Now you can solve a problem. Evaluate integral 0 to 1 by 1 plus x dx using Romberg integration. So taking h is equal to, so here now first step you have to divide this interval. So here we are dividing the intervals into 3, that is we are taking h is equal to 1, then h equal to 0.5 and h is equal to 0.25. Okay. So when h is equal to 5, value of x and f of x will be this one. So when h is equal to 0.5, value of x and f of x will be what? This one. Okay, when h is equal to 0.25, this will be the value of f of x. So while dividing it into, if you are taking step size as 0.25, then there will be how many intervals? 1, 2, 3, 4, 5 intervals. Okay. So these are the values of f of x when x is equal to 0, 0.25, 0.5, 0.75 and 1. Okay, so first you have to tabulate it. After that you have to find the value of I0, I1 and I2. How can you find the values of I0, I1 and I2 is by using trapezoidal formula. So this is trapezoidal formula. So by using trapezoidal formula you can find the values. So I0 is the value corresponding to the step size h is equal to 1. So now you have to look at this table. When h is equal to 1, x0 equal to 0 and y0 is equal to 1. Then yn, y0 equal to 1 is it, and yn is equal to what? 0.5 and y1, yeah, y0 is equal to 1 and yn is equal to 0.5. Now you have to substitute the values in this. So you will get it as 0.75. Next you have to find I1. I1 is the value corresponding to what? H is equal to 0.5. So when h is equal to 0.5, you have to consider this table. This is y0, this is yn and this is y1. So substitute the values in this. Substituting you will get it as 0.71, and in case of I2, when h is equal to 0.25, you have to consider this table. Okay, so here y0 will be 1 and yn will be 0.5 and this will be y1, y2 and y3. Substitute the values in the equation and find the value for I2. After finding this I0, I1 and I2, you have to find I1 dash and I2 dash. So I1 dash will be 4 by 3 I1 minus 1 by 3 I0. Value of I1 and I0 have been found earlier, is it? So substitute these values in this equation and find I1 dash. Again I2 dash is equal to 4 by 3 I2 minus 1 by 3 I1. So I2, I1 value we have found earlier. Substitute those values and you will obtain it as 0.6933. After finding this I2 dash and I1 dash, you have to find I2 double dash in order to obtain the value of the integral, is it? So taking I2 double dash equal to 16 by 15 I2 dash minus 1 by 15 I1 dash. So I2 dash and I1 dash have been found above. Substitute those values and you will get the value of I2 dash as 0.6931. Thus the value of integral will be 0.6931. 6931. Okay, this is Rombergs integration method. And we can start the next module in the next class. Okay.